Today we will be covering growth and decay. On this first example, we're actually going to talk about exponential growth. Now, when it grows from yesterday, you should know that your function looks something like this. So you have, from left to right, you have it going, increasing. Okay, so here's the equation that this is going to take. So if it's a growth, you're going to take your initial amount and you're going to add it to the rate, 1 plus the rate, and then you're going to raise it to the t, which is time. So if we look at this first example, it says a town has a population of 48,000 in 2011. Then the population increased by 8% per year for the next 5 years. Write an exponential growth model for the town's population over a 5-year period using the model to find the population in 2014. Okay, so because we're talking about growth, we're going to use this formula, and I got to find my A and my R. Well, my A is my initial amount, which is 48,000. Now, I kind of forgot to mention, when you're dealing with the rate, it has to be in decimal form. So it's going to be a number between 0 and 1, usually. Okay, so on this particular problem, it tells us that the percent is 8 per year. Well, 8% in decimal form, you're going to take the 8 and you're going to divide it by 100. Some of y'all just know to move the decimal 2 places to the left. So this is the number that we're going to use, 0.08. All right, so plugging in that equation, y equals the initial amount, 48,000, times 1 plus 0.08 t. Now, some answer choices, if it was asking you an answer choice, may take it a step further and add these two numbers. It's not necessarily necessary, but you can add them together. So anything above 1 you should know is a growth inside. If it's below 1, it's a decay, which we'll talk about in a minute. Okay, so now I got to figure out what the population is in 2014. So real quickly, I'm going to write this on the side. You have 2011, which is your initial year. 2012, 2013, 2014. Oops, forgot the 0. So this is 1, 2, 3. So we're actually looking where t is equal to 3. So we're going to put this in the calculator. I'm going to go ahead and put that exactly the way I see it. Okay, so now I'm going to go ahead and go to the table, and I want to go to year 3. Well, year 3, we're going to round to the nearest dollar, would be 60,466. So that would be our second answer to this particular problem. So this would be in 2014. That's the population. So in 2014, you had a population of 60,466. Okay, so let's take a look at the next one. Let me give you a few seconds to copy that down. All right, so this time we're going to graph it. So we kind of talked about graphing yesterday. I'm going to put this in the calculator. 2 times 3 raised to the x power. I'm going to go to second graph, and it specifically wants the numbers -1, 0, and 3. So 0.6 repeated is 2/3. Then we have 2 and 6. So I have 2/3, 2 and 6. So now I'm going to graph those points. So -1 2/3, not quite 1, but pretty close. 0 2 and 1/6. And again, it's a growth, so we know it's increasing. All right, so that's exponential growth. Let's talk about exponential decay. So exponential decay, very similar with the exception of the minus sign. So this signifies the decay. So again, you have your initial amount, your rate as a decimal, and your time. Okay, so between 2010 and 2014, the profits of a business decreased by approximately 0.5% each year. So we have our rate, and the business profit was 1.2 million. Write an exponential decay model showing the business's profit in T years. What was the profit in 2014? Okay, so y equals a times 1 minus r to the t power. Our a is 1.2 million. Our r is 0.5%. We should be moving it 2 places to the left, but to show you in the calculator, 0.5 divided by 100 is 0.005. So this is the number that we'll be using. And now we're going to plug it in. So y equals 1.2 million minus 0.005. Okay, so when we subtract those two, 1 minus 0.002, I get 0.995. Okay, so real quick, I'm going to sidetrack for just a second. Okay, remember I told you the decay is going to be a number less than 0? I'm sorry, a number less than 1. So if you look here, that number is less than 1. Your decay is going to be greater than 1. I mean, your growth will be greater than 1. So here we have a number greater than 1. That's how I know it's a decay. I mean a growth, sorry. Your decay is less than 1. That's when you know it's a decay. So we know that we should, at this point, we know we're okay because this is a number less than 1, and we're talking about decay. All right, so let's put this in the calculator. Okay, so we want to know what the profit is in 2014. So just like before, we're going to do 2010, 2011, 2012, 2013, 2014. So if you look, you don't count your first year. So 1, 2, 3, 4. So we want to know what the answer is when x is 4, or when t is 4. So I'm going to go to second graph, and I'm going to go down to 4. So here's the number, and it's a big number. I'm around to the third decimal point, so 1.176. So in 2014, the profit was 1.176 million. Last problem. Again, if you look inside the parentheses, that's a number less than 1. Number less than 1 is going to tell you that it's a decay. Number greater than 1 tells you it's a growth. Okay. So I'm going to go to the table, second graph. So it wants negative 1, 8, 0, 4, and 1, 2. So here I'm going to put 8, 4, and 2. And now I'm going to graph those points. Negative 1, 8, 0, 4, 1, 2. And again, because it's a decay from left to right, it decreases. And it never touches the x-axis. It never crosses it. So growth and decay. Again, I'll try to explain one last time. If the number inside the parentheses is a number less than 1, then it's decay. If the number inside the parentheses is greater than 1, then it's a growth. So if that number is greater than 1, that number is greater than 1. That's a growth. Here, the number inside the parentheses, they're both less than 1, so they're both decays.